everyone. Welcome back to part 2 of our Netezza DBT series. In part 1, we introduced the basics of Netezza DBT and why it's such a powerful tool for analytics engineering. Today, we're diving deeper, creating real-world models, seeding data from CSVs, and even working with incremental models. And yes, all of this using a real use case inspired by Airbnb's massive data workflows. Let's get started. Imagine I'm tasked with analyzing tons of Airbnb customer reviews. The problem? The data is raw, unclean, and scattered. The first step? Load that raw data into our database. Here, I'm loading CSV files into the database. Notice these tables have a raw prefix, for example, raw reviews. They're not ready for analytics yet. Messy column names, inconsistent values, all over the place. Now that we've loaded raw data, the next step is to create and run Netezza DBT models. Here's how it works. First, we create staging models inside the SRC folder. These models pull data from raw tables, rename columns, and apply basic cleaning. Then we create dimension and fact models like FCT reviews inside the DIM or FCT folders. These models build on staging models to give us structured, report-ready data. Once the models are created, we run them using the dbt run command. As the console runs, notice that some models are materialized as views, which means the SQL runs every time you query it, while others are ephemeral, which never create physical tables but are inlined into downstream queries for efficiency. Next up, seeds. Suppose I have static datasets like Airbnb region codes or currency conversion rates stored in CSVs. Instead of writing SQL for them, I just use Netezza DBT seed to load them directly into the database. Here's the CSV. Then I run DBT seed and boom, the data is now in my database as a table, ready to join with my models. Now let's talk about incremental models, a game changer for large data sets. Here's the problem. I don't want to refresh millions of Airbnb reviews every day when only a few new reviews come in. The solution? Netezza DBT's incremental materialization. Here's an example. We have a fact model called FACT_reviews. Inside the SQL file, I use the is_incremental function to tell DBT. Only insert rows where review date is greater than the maximum review date already in the table. Now let's run it. First, a full load. Then I add new reviews to the raw table and run it again. Notice how only the new rows are added. That's incremental modeling at work. Before we wrap up, let's cover Netezza DBT snapshots, a powerful feature for tracking historical changes in data. Suppose I'm monitoring Airbnb listing data, and I want to track how fields like minimum_nights change over time. Netezza DBT snapshots let us do this, almost like version control for data. Here's a snapshot definition using the timestamp strategy, tracking changes based on the updated at column. Now I run DBT snapshot. I update a listing's minimum nights value, then run the snapshot again. Check the table. There are now 2 records for the same ID, showing both old and new values with valid from timestamps. That's how we keep historical versions without overwriting data. So to recap, we created raw tables, cleaned them with Netezza DBT models, seeded external CSVs, built incremental models with FCT_reviews, and even tracked historical changes using snapshots. Netezza DBT simplifies and scales analytics workflows, whether you're at a startup or a giant like Airbnb. If this helped you, hit like and comment for more engineering stories from the real world. See you next time!